Today we're going to talk about analyzing and sketching graphs. So sometimes we're going to look at graphs a little bit more of a generic look, and we're going to look at them in more of a what is generally happening without having numbers. But we can still find out some information. Certain things will be definite about them, while some of the information is, a little bit to the imagination. So graphs can show the relationship between quantities without using specific numbers. So notice here on this example, this y-axis is looking at the distance, but it's not showing us what the number is where this distance is crossing the y-axis. So we have no idea. We don't know if it's at 0 and then this is 1. This could be at a half and 1 is up here. This could be at 100. We don't really know. Same thing here in time. We don't really know what it's changing by with the time. There are no numbers. But we still can figure out some information to read the information in the scenario and kind of see what's happening. So clearly this first little section here, we would say that this is increasing, right? It's definitely going bigger from left to right. We always read our graphs left to right. Then when we see something where there's no change, if you think about it, time is still going forward. So let's just say, for example, let's just say this scenario was the distance that I'm riding my bike from my house to my neighbor's house. Well, the distance as I start biking, as time goes on, if I'm going towards my house, like I'm going away from my house towards my friend's house, my distance is getting more and more and more and more. So maybe I stop at my friend's house, but time keeps going. So even if I've stopped for a little while, the distance is just going to stay. So we call this no change or a constant. Then as I'm coming home, the distance would be coming back closer till I got back to my house. Okay? And obviously when you look at decreasing here, it's definitely dropping. It's like a negative slope. Notice how this slope is much steeper than this slope over here. So this would tell me that we were going slower over here than when I was coming back at the end. So let's go through a couple of more examples. So here we have two graphs that are showing the temperatures throughout a day in two different cities, Belfast, Maine, and Newport, Oregon. Again, we don't have any numbers on the temperatures. We don't really know if this is 10 degrees or if it's 100 degrees. We just know that that's the temperature at the beginning of the day. Same thing here. We don't know what this is, okay? But we still want to talk about what are we seeing happening during the temperature change throughout the day. We also don't really know if this is like midnight to midnight. I would assume it's throughout the day. So I'm going to go on the assumption that this is kind of throughout the day, so that maybe we could say this right here is about halfway, so noontime. But we don't really know. But based on the wording throughout the day, I'm going to kind of go by that, how I make my descriptions. So describe the change in each city. So let's look at Belfast. So let's do Belfast. So again, we don't have numbers to be able to write this, but we can basically say what we think is happening. So I'm just going to pause the video for a second. Think about what you're seeing happening, and then when I come back, I'll explain what I did. So here you can see how I wrote this. So basically what I'm saying is the temperature warmed up to its highest temp around noontime. So here we can see that we kind of peaked at our temperature. We kind of climbed up to about noontime, and then we kind of decreased the rest of the day. And then I added this one little piece that it ending a little bit warmer than it started. It's a little bit higher than when we started the day here at the end. Again, I don't know if that's 5 degrees warmer, 10 degrees warmer, 20 degrees warmer. It's just a little bit warmer at the end than it was at the beginning. So something like that would be fair. So then I'm going to look at what happened in Newport, Oregon. So again, let's pause the video and then come back. You think about what you think is happening. So as I'm describing this one, what I'm saying is that in Newport, the temperature dropped And I'm saying till about mid-morning. So again, I'm kind of going on the idea that this is about halfway, so this would be about noontime. So it dropped until about mid-morning. Then it stays the same until about mid-afternoon, and then climbing slightly the rest of the day. Now I didn't put anything more detail on this one about how it ended up cooler at the end of the day than the beginning, which you could have. Could have said that it dropped significantly and quickly in that first bit to show the difference between this one. But again, those are just two ways you could have described this, and for those two different cities. So then to write an explanation for the decrease in temperature and the increase in temperature for Newport. So this is where I was kind of saying you could have been a little more specific. You could have said the temperature dropped more quickly at the start of the day and increased more slowly to end the day. Now, obviously, you could have said something in there about, an explanation. So maybe there was a pretty big cold front that came through, and the temperature dropped quite a bit, kind of stabilized around the noontime, but then we started to get a warmer weather coming through. But to me, the temperature is dropping more quickly in the beginning of the day, had a little bit of a steady, kind of around noontime-ish area, steady temperature, and then climbed a little bit more slowly just to finish out the day. So next we want to look at how do we sketch one of these things. So we're going to give a situation here on the subway where we're going to give some information and we're going to draw out the sketch. What is our graph going to look like? So when I think about what's going on here, we're going to make a graph through all these parts. So in the first column to the left here, I'm going to just do a quick sketch of what I'm seeing happened. Then the words, we're going to kind of break down what we're seeing, different parts of this. And then the graph over to the side, we're going to kind of make our graph, including all of these parts. Okay, so we're going to have our axes. The vertical axis is going to be speed, and the horizontal will again be time. Okay, now again, we're not going to have any numbers on here. We're going to sketch out this graph as we see it happen. Okay, so a subway gains speed at a constant rate until it reaches maximum speed. So what is that really telling me? Well, a constant rate. So we've heard this word constant rate of change a bunch of times. Constant rate means the speed is adding more and more and more. Gaining would be getting faster, but it's going at a steady rate. So thinking of constant rate, that's telling me that I'm going to have a straight line increasing as I go from left to right. So I'm just going to, under the sketch line, just something like this. Now, I don't know how fast it's climbing, but it's some sort of a straight line. Okay? Now, if you think about it, a stopped subway. Thinking about our speed, where is a stopped subway? Well, that would be a 0 speed. So that means we're going to start at 0 for our speed, and we're going to gain until it reaches maximum speed. So on my big graph, I'm just going to do that. Okay? Now, I don't know how fast it's climbing. I don't know how fast maximum speed is. So I can't really do anything more than just what I think. Okay? But let's move on to the second part. It then travels at this speed for a while. Okay, so this speed. So right here would be the maximum speed, right? So it's going to stay at that speed for a little while as time goes on. It's not going to get more, it's not going to get less, it's staying at that speed. So with that in mind, and again, for a while, a little bit of interpretation on that. You might think it's a short little while, somebody else might think it's a long little while, but it's going to stay at that same speed. So it's a horizontal line during that time. It's not getting faster or slower. And then it slows down, so it's going to go down at a constant rate until coming to a stop at the next station. Again, constant rate means straight line, and this time it's coming down. So again, also to a stop means it goes all the way to 0 for our speed. So it's going to look something like that based on that phrase that we just saw, the sentence we just saw. That would be a reasonable graph of the speed of the subway train as it gets faster to that maximum speed, holds that speed for a little bit, and then comes back down to a stopping point. So we have been talking about constant speeds, and we've been talking about constant rate of speed. This one actually includes something where we have to think about this curve, this runner B having a curve. So the graph is showing the distance traveled by two runners in a race from start to finish. So we can see that they're both starting here, and then as time goes on, you can see some different things happening with what they're doing. Okay, so we want to first describe each runner throughout the race. All right, so let's just look at runner A. Okay, so increases speed at a constant rate for a while. Okay, then notice that his distance stops. He's not gaining any distance through here, right? So he goes pretty quick out of this thing, right? But then his distance stops for a little while. So what is that telling me? Well, we don't know why. Then I'm putting he, but it could be she, it could be anybody. Then he stops for a while. And again, we don't know how long, but he stopped for a little while because his distance didn't go any further. Okay? Then increases speed at a constant rate again. That's runner A. So now runner B. So this one is tricky. So runner B. He starts at a slower pace, but increases at an increasing rate to finish. And let's talk about what I mean by that. So, when I look at this one, runner A, he is increasing his distance at a constant rate. His change in y over change in x is the exact same slope. He's going at a same steady pace. Then he stops for a little bit, so his distance doesn't change even though time does. And then he picks up again at that same very steady pace. Okay? The other person, the other runner, starts out slower. This person is going more distance over time than this person is covering until about here, right? And it's a pretty constant rate here, but it's definitely a slower rate. Okay? If you think about it, a race is a distance. You're racing to a distance. So for example, if the race was just to this point right here, A gets there faster because they hit this point at a faster pace than runner B, who hit that same point, who took a lot longer to get there. Okay? But at some point, runner B, so notice how this thing is curving. So runner B, who was going at this speed, all of a sudden is now going at a much faster speed. We call this an increasing rate. So if you think about it, the slope here starts becoming sharper and sharper and sharper, and because it's a changing slope, it's called increasing rate. So let's say the slope was 5 feet per second, then it was 6 feet per second, then it's 7 feet per second, then it's 8 feet per second. It's kind of going from one pace to a much faster pace to get here. A little bit trickier. It's definitely trying to understand what that means, but basically you can think of it as that slope is going faster, so it's curving the line now because it's not the same slope between all the points. So then the last question says, well, who wins the race? Well, again, the finish line is set at a certain distance. We don't know what that distance is, but I'm going to use that green line as showing us the distance. And the question is, who hits it first? Our first reaction, I think, by a lot of us, is to say, oh, well, the red one's in front, so they're in first place. But again, if this is the distance that you are supposed to meet in the shortest amount of time, actually the blue person makes it in a shorter amount of time. So to answer the second part, who finishes first? Runner B. Finishes first. They made the distance in a shorter amount of time, so they would be the winner. So these analyzing and sketching graphs without numbers can be tricky. It's a little more of a comprehensive thing, just trying to understand the situation and what the lines could represent. There's a little bit of gray area between different things. There's a little bit of your interpretation of stuff, but we still should be able to get some sort of graphs that are consistent, and you should be able to kind of back up your graphs with the information if we had a discussion about that. So if you have any kind of questions or problems, please see me in class, and we will work on these together this week.